See the topic reflection from curved surface. A curved surface will be formed from a spherical type of objects. So just this curved surface is just a part of curved spherical surface or spherical body. So curved surfaces is a part of spherical body. So now you can take in one type of spherical body. Uh, See, like this, if you take next way as a one spherical body, okay. Uh, like this, if you take next way as a one spherical body, na? So if certain part of this spherical body is taken, so certain part of spherical body, let us you can take it, cut this spherical body, uh, certain part. So now this cutting part, so you can take in the cutting part from the spherical body, you can take in as way as like this one spherical body we need to take. Now center of this spherical body, the curved surface is a part. Let us take in it is the center of spherical body, the curved surface is apart. You can take next way as the center of curvature. So center of curvature, center of curvature, and the midpoint of the spherical body, the geometrical center or midpoint. So geometrical center of surface or midpoint of surface. So we need to take next way as a pole. So just that word you can take next way as a pole. Now an axis passes through center of curvature and pole you can take next way as principal axis. Like this, if you take in one axis and if this axis if you take next way as it is passes through center of curvature and pole, then this axis we can take next way as principal axis. Okay, so this axis we can take next way as principal axis. Okay, so these are all the basic terms belongs to spherical surfaces. One is center of curvature, second one is pole, and third one is principal axis. Next, you can go with radius of curvature. Radius of curvature denotes with r. So it is just a distance between center of curvature to pole. Distance between center of curvature to pole. So you can see the diagram. Uh, the So it is the location of center, and here you have a pole. Therefore, distance between center of curvature and pole you can take next as the radius of curvature. And next, we'll go with one more point is paraxial rays. So paraxial rays. So paraxial rays are the rays are which either parallel to principal axis. So parallel to principal axis or make small angles with makes small angles with small angles with principal axis. So principal axis that rays you can take as we as paraxial rays. Let us say for example if you take it is your curved surface or and here you can take as a principal axis a light rays which is parallel to principal axis and makes very small angles with the principal axis, or you can take as a paraxial rays. Next, next topic is focus. See, so we need to take an focus. So focus is we can take an just image location. So focus is image location for object is at infinity. Image location for object at infinity. Now you can take in two different types of mirrors. Let us say, for example, it is your convex mirror, and here you can take as a concave mirror. Okay, and it is you can take as a principal axis for the concave mirror, and it is you can take in principal axis for the convex mirror. Just it is you can take as a principal axis. Now, light rays comes from the object is at infinity, means light rays parallel to principal axis. So parallel to principal axis. After incident the parallel light rays on the curved surfaces, it reflects from the surface and converges to a one point. That point we need to take as a focus. So this location we can take as focus point. That is, we can take as F. Similarly, for concave type of convex type of mirrors, light ray will be incident on the surface like this. Then light rays will be reflected from the surface with the certain amount of angles. Like this, light rays will be reflect back from the surface. So if you are extended backwards, so the diverging point of from the curved surfaces you can take as focus. Like this, you can take as a focus. Now you can after find out the focus location. So focus location. So here you can see focal length. Focal length. So focal length of given surface will give the nature of surface. See, focal length is nothing but it is just a distance between pole to focus. Distance between pole to focus. See, if you are taken, it is your pole. It is a geometrical center of the surface or mirror, and it is your focus. And distance between pole to focus you can take as a focal length defined with F. And here it is you can take as a pole, and here if you take as a focus, therefore distance between pole and the focus you can take as a focal length. See, depends on the focus. So we will give the nature of image. So based on focal sign convention of focal length. See here. So if focal length if you take as a positive, so focal length is positive na, that type of surfaces is having positive divergent nature. So the type of surfaces having divergent nature of mirrors, divergent nature of mirror. So divergent nature of mirror is convex mirror. So for convex mirror, focal length is positive. That mirror having a divergent nature. And the focal length, if you take as a negative, so this is called as a convergent mirror, convergent nature of mirror, convergent nature of mirror. So convergent nature of mirror is concave mirror, concave mirror. So like this, depends on the focal length, we will find out the nature of mirror. If focal length is positive, divergent nature, focal length is negative, convergent nature. Next, last one, we will go with the power of a mirror. So power of a mirror. See, power you can define as negative reciprocal of. So negative reciprocal of reciprocal of focal length. Negative reciprocal of focal length. So you can define as power of a mirror. Therefore, power of a mirror you can define with P. So power of a mirror P equal to minus 1 upon F. So if Focal length, if you're defined with p na, then power of mirror you can take as as a diameter. So power of mirror you can measured in terms of diopters. Okay. We next concept, sign conventions for mirrors. Sign conventions for mirrors. So here basic sign conventions is mandatory. Okay. Letters you can take in this direction light rays will be traveling. So it is the incident light ray. Incident light ray. So here directions we need to give in the direction of incident light rays. So in this direction, if you are given incident light rays, now taken it is your Cartesian coordinate system. Like this, one Cartesian coordinate system you can take. The pole taken as origin. First sign convention we need to take in. Origin is placed at pole. Origin is placed at pole. Next, all distances, second rule, all distances measured from pole. All distances measured from pole. All distances measured from pole. Next, third point, distances measured in the direction of incident rays. Distances measured in the direction of in the direction of in the direction of rays, incident rays taken as positive, taken as positive. So distances in the direction of incident rays taken as positive from pole. Similarly, fourth one, distances measured distances measured opposite to direction of incident rays, opposite to direction of incident rays taken as negative, taken as negative. Next, fifth rule, heights or distance. So you can take as well as distance. Distance, distance above principal axis, distance above principal axis taken as positive, taken as positive. Next, last one, sixth one, distances, distances below principal axis, below principal axis taken as negative. So these are all the basic sign conventions in ray optics. Not only in reflection, even in refraction also the same sign conventions we need to follow. See, the all six rules we need to uh, represent in a single diagram. See here. See, in this direction, light rays will be incident, and origin you can take as P as a pole, and from the pole in the direction of incident light rays, so means in this direction, taken as to be as a positive, and opposite to direction of incident light rays means in this direction, taken as negative. and distances above the principal axis taken as positive, and distances below the principal axis taken as negative. And all distances should be considered or should be measured from the pole itself. That's why pole you can treat it as the origin. Now, one more sign convention we need to make. Let us you can take in it is your principal axis and it is the pole. There is no doubt about it. Now, incident light rays will be moves in this direction. So, it is your incident ray direction. Incident ray direction. So, in this direction, light rays will be come now from the pole in the direction of incident light rays taken as to be as a positive. From the pole opposite to direction of incident light rays taken as to be as a negative. Heights above the principal axis taken as to be as a positive, and the distances below the principal axis we need to take as to be as negative. So it is your principal axis. Like this sign conventions we need to follow. It will be depends majorly depends on. So sign convention majorly depends on incident ray direction. Incident ray direction. Okay. So it is the major point to remember in sign convention of light rays. Okay. Majorly sign convention in ray optics depends on incident light rays. You can see rules for obtaining images by ray tracing. So here we are following 5 different types of rules. First one is any light passes parallel to principal axis reflects through focus. Any light passes parallel to principal axis passes parallel to principal axis. It reflects through focus. Let us take an it is your principal axis and any light ray passes parallel to principal axis like this. It will be incident na. It reflects through focus. It reflects through focus. That is the first rule. So first rule is any light ray passes through principal axis reflects through focus. Second one, any light ray passes through focus reflects parallel to principal axis. Ulta for this configuration. Therefore, the same light ray you can take in opposite direction. Third one, any light ray passes through center of curvature retraces its path. Why? Because for a given curved surfaces, center of curvature gives the normal. Therefore, any light ray which is passes through center of curvature and retraces its path. See, if I'll taken one light ray which is passes through center of curvature and incident on the surface, and again it retraces its path. In this direction it is incident na, and in the same direction it will be retraced. Like this, you can take in it is a third rule. Any light ray passes through center of curvature, it retraces its path. Next, fourth rule. Any light ray incident on pole reflects symmetrically. Now here you can take one light ray will be incident at the pole. Like this, you can take in one light ray will be incident at the pole. At the pole, if your principal axis is act as a normal, therefore light rays will be reflect symmetrically to this to that particular point. Okay, copy. And same rules we need to follow for the convex mirror also. Any light ray passes parallel to principal axis. Like this, any light ray will be incident on convex surface na, and it will reflect or convergent or reflected through focus na, or here appears to be reflect from the focus. Like this, if you are extended backward direction, it will be appear from the diverging from the focus. And ulta for this one, any light ray will be incident through the focus reflects parallel to principal axis. Second one, any light ray passes through center of curvature. Like this, any one light ray will be incident on the curved surface, and this light ray which is appears to be incident through the center, then it will be retraces its path. Next, any light ray incident on the pole. Like this, if you taken one light ray which is incident on the pole like this, then it is reflects symmetrical to through the principal axis. Like this, light rays will be reflect from the convex mirror. And one more point also we need to remember. So parallel beam of light. Let us we can take in it is our concave mirror, and it is our principal axis. One parallel beam of light will be incident on like this. Parallel beam of light will be incident on the surface. So these parallel beam. So let us here you can take as we as a focus. So if you taken that is a focus, first we need to line one line perpendicular to focus. One line perpendicular to focus. Within the line in the sense, we can go with it is like this. One line we need to write. Or this a plane passes through this line, you can take as a focal plane. And first you can extend it. This light ray will be incident at the pole. Then this light ray will be intersect the focal plane at a certain point. Then definitely remaining all the light rays is also passes through that point only. And this line is also passes through this point only. Like this, a parallel beam of incidence which is on the curved surface, it reflects from a focus plane. And here uh, we need to take in this axis or plane, you can take as a focal plane. So focal plane in the sense, a plane perpendicular to principal axis, a plane perpendicular to principal axis, perpendicular to principal axis is called as and passes through focus. A plane perpendicular to principal axis passes through focus. Passes through focus is called as a focal plane. Any parallel beam of light will be incident on a plane mirror na, that will be reflected through a focal plane. Okay, or if you're taking the same points belongs to concave or convex surface, means inside we need to count. Now it is your parallel beam will be incident on this convex type of mirror. Then so you can see it will reflected like this, and focus will be appear over here. Then you can draw one line perpendicular to the principal axis and contains with the focus. Now you can extend this incident light ray, and here this light ray, reflected light ray will be uh, intersect to each other. Now these all light rays will be reflected through that point of projection like this. So now okay, extended backward direction, all reflected light rays appears to be diverged from the focal plane point. Okay. Next concept, relation between focal length of and radius of focal length and radius of uh, curved mirrors. Relation between focal length and the radius of curved mirrors. See, let us you can take in it is your curved mirror. So let us you can take in it is your curved mirror, and having it is your pole of a given mirror, and it is a focus. Let us assume it is your focus point, and here you can take next as the center of curvature C. Now, if you are taken one light ray will be incident from the one light ray will be incident on the plane surface. Like this, one light ray you can take incident on the plane surface. One surface, one light ray. We need to take in light ray. Like this, one light ray we need to incident on the plane surface. Now, at this point we need to make a normal. So at that point we need to make a normal. Any normal which is passes through center of curvatures like this. A normal we need to draw. Okay, that is the normal point. So and normal, and after incident the light ray, it will reflect the point. Already we know I'm given any light ray passes through parallel to principal axis. It reflects through focus point. Like this, light ray will be reflected. Okay, so light ray will be incident like this, and it will be reflected like this. So then, so we can use the use now that solar triangles principle. Let us, it is your incident light ray, and it makes an angle theta with the normal, that is angle of incidence. And here also reflected light ray makes an angle with So reflected ray makes an angle with normal. That is, you can take an angle of reflection. According to law of reflection, angle of incidence equal to angle of reflection. That is also I. Now, let us you can take here the angle of incidence is I. Na? Then, what is the angle here? So, angle of incidence is I. Why? Because it is a parallel axis and it is a parallel axis. Use the parallel axis theorem. If it is angle of incidence I, na, then here also angle of incidence you can take as to as I. So you have a one rule, triangle rule. Sum of the interior angles of a triangle equal to one exterior angle. Therefore, here angle we need to take as to as 2i. Okay. So here angle is 2i and here angle is I. Now if you're taken it is a P and point of incidence you can take as to as a P dash. Now from the triangle P, P dash, F. Why? Because it is 2i. From the triangle P, P dash 2f, tan 2i. So tan 2i that must equal to P, P dash divided by P, F. Okay. Next. From, so take this equation number 1. Take this equation number 1. From the triangle P, P, P dash. So tan I. So tan I you can take in. So P, P dash divided by C, P. For small angle of incidences, for small angles, tan theta is approximately taken as to be as a theta. Tan theta is approximately taken as to be as theta. Therefore, from the equation 1, you got 2 times of angle of incidence is approximately equal to, so P, P dash divided by P, F. And from the second equation, you got tan I is nothing but I. That is approximately equal to, so P, P dash divided by Cp. Now you can substitute I in this equation. You got 2 into, so P, P dash divided by C times of P. That must equal to, so P, P dash. So okay, you can take an approximated value. P, P dash divided by, so P times of F. So P, P dash, P dash get cancelled. From this equation, you can take 2 divided by C times of P that must approximately equal to 1 divided by PF. Already we know that distance between pole to focus is nothing but focal plane, focus. And here incident light rays from left to right. But for focus, we need to calculate opposite to direction of incident light ray. Therefore, focus we need to take as to be as a negative sign. In the similar way, center of curvature, radius of curvature is also we need to calculate opposite to direction of incident light rays. Therefore, radius of curvature also we need to take as to be as a negative. So PF you need to take as to be as a minus F, and PC you can take as to be as a minus F. So hence, so here you got 2 divided by, so here you got 2 divided by minus r that must approximately equal to 1 divided by minus r. Therefore, minus minus get cancelled. With 2 divided by minus r equal to, so 1 divided by minus f. Now minus minus get cancelled. Therefore, radius of curvature r is approximately equal to 2 times of focal length. For paraxial rays point of view, for paraxial rays point of view, radius of curvature of a given curved mirror equal to 2 times of focal length of lens. So radius of curved mirror that equal to 2 times of focal length of lens or focal length of mirror. Okay. Next, mirror formula. Let us you can take it is your mirror. Let us you can take in it is your mirror, and so consider it is the pole of the mirror taken as P and one object we need to take an over here. Let us you can consider it is your object O. And see from the object we need to take in two different types of light rays. Two different types of light rays. So one is along the principal axis, from the origin along the principal axis, like this. One light ray and make certain angle with, so one light ray along the principal axis taken, that is like this, and one more light ray is make certain angle with the principal axis, like this we need to take. So that is one more light ray which is incident on the plane level. At this point we need to make a normal. So normal at the point, so definitely if you take in, it is your center of curvature. A line passes through center of curvature, gives the normal at that location. Therefore, so here we need to draw one normal like this. So it is your normal taken as to as N. Now, and it is, if you take as to as, it is your incident light ray. Incident light ray makes an angle with normal. This called is angle of incidence type. Angle of incidence type. After incident on this one, light ray will be reflected back. Light ray will reflected back from this point, and like this it will be reflected. Okay, so it is a reflector light ray, and so already we know that angle of incidence must equal to angle of reflection, and here it is also we need to take as angle of incidence. Now, and here one light ray will be passes along the principal axis and it is retraces its path. Now here two reflector light rays will be meet at this point. So this point you got image. So the convergent point of reflector light rays on the principal axis we take it as to be as the image point, and it is your object. Now, so here distance between pole to object. So distance between pole to object is taken as to be as object distance. Is taken as object distance. So denotes with u. Object distance denotes with small u. And distance between uh, pole to center of curvature denotes with the radius of curvature. Denotes with radius of curvature. And pi, distance between pole and image is called as image distance. Is called image distance, taken as to be as v. Now sign conventions we need to take. Object distance from the pole. So light ray will be incident in this direction. So it is the incident ray direction. But we need to measure. So we need to measure all the distances from the pole, means in this direction. Taken u is negative as well as v is also negative, and center of curvature is also we need to take as a negative in the final point of view. Now you can see the triangle. It is, if you take as as a pina, and here also you can take in one point, that is point number p dash. Now here in the triangle O P dash C, triangle O P dash C. Now if you taken here the angle, if you are taken incident ray makes an angle with the principal axis is alpha, and normal makes an angle beta with the principal axis, and reflected ray makes an angle gamma with the, where alpha, beta, gamma be the angles subtended by incident ray, normal and reflected ray. See, from the triangle O P dash O P dash C, alpha and I be the interior angles and beta is the exterior angle. Therefore, sum of the interior angles alpha plus I equal to beta. From this you can take an angle of incidence is beta minus alpha. Take this equation number 1. Next, from the triangle C P dash I, C P dash I. See, beta and I be the interior angles and gamma is the exterior angle. Therefore, beta plus I equal to gamma. From this equation, angle of incidence I equal to gamma minus beta. Take this equation number 2. Now, equate 1 and equation 2. So, equation 1 that must equal to equation 2. Why? Because angle of incidences we need to common out. So in this case, so beta minus alpha that must equal to gamma minus beta. So from this equation you got alpha plus gamma that must equal to 2 times of beta. Alpha plus gamma that must equal to 2 times of beta. So for small angles, theta you can take as as a tan theta. So therefore, for alpha you can take as as a tan alpha plus gamma you can take as as a tan gamma, and 2 times of tan beta we need to take. 2 times of tan beta. Now substitute these tan values from the graph. So tan alpha, for the alpha, tan alpha is nothing but, so p dash divided by p times of c plus tan gamma. So p dash divided by p times of I. Tan alpha, no, it is PO for alpha, PO plus PI, that must equal to 2 times of tan gamma is nothing but, so tan beta. So tan beta point of view, P dash divided by P times of C. Now P dash get cancelled on the both sides. So PO, distance between object to, no, pole to object, is your object distance taken as to be as minus U, plus 1 by distance between pole to image taken as to be as a minus p, that must equal to 2 divided by distance between pole to center of curvature is radius of curvature minus r. All sign conventions get cancelled. Therefore, final answer you got 1 by u plus 1 by v, that must equal to 2 divided by. So already you know one formula, uh, r divided by 2 is nothing but f divided by 2. From this equation, one more formula you can take, that is 1 by v plus 1 by uv equal to 1 by f. So it is the formula belongs to curved surfaces. Whatever it may be the surface we need to follow, just we need to follow sign conventions to solve the problems.